Please welcome the next speaker on stage, Albert Padin, co-founder and CTO at Synth.
Hello. Can you hear me? Hello. If you can hear me, clap your hands again. Oh yeah, okay, that's great. All right, so, hi, I flew from the Philippines, so let me just show you a little bit of what I do. Okay, here we go. So I come from a company called Synth, where we're basically web development, mobile app development shop. We basically do websites and mobile apps for clients, for money. That's what we do. And wow, this is a long walk from there to here. So awesome stage. So what I'm going to be sharing to you today is about artificial intelligence and machine learning. So just a show of hands, who here already is doing machine learning? Like, raise your hand. 5 people. All right, but who here has heard about machine learning? Everybody, right? So let's change that, right? I want it to be that after today, we move like the ratio of people who've heard about machine learning to people who've done machine learning. Can we do that? Yeah, that sounds great, but we don't really know what it is. So let's change that. All right, so about a year ago, I was invited to do a talk to students and to share about what I do, specifically about artificial intelligence. And I was like, sure, I've given like over like hundreds of talks and this is not gonna be a problem. Except that these were kindergarten students. You know, like toddlers, right? Like 5 years old, 6 years old. And I was like, how do I explain AI to these kids? And so I was completely terrified because, you know, like kids, they're honest, right? Like adults, like I would give a talk even if you don't sound really okay, even if you don't give a good talk, adults will still clap, you know, they're polite, you know. You ask them, how was it? Like, oh, pretty good, yeah. Learned something new. But a kid, they're honest. They'll be like, if you're boring, they'll be like, this is boring. Like, teacher, can I like go out? Like, I was so afraid it's gonna be devastating to my self-esteem. So I really prepared for this. And today, I'm gonna give the same talk, all right? So how do you explain machine learning? What is machine learning? So I asked, okay, who here knows what a lion looks like? Raise your hand. A lion. You don't know what a lion looks like? Okay, so no judgment here, but if you do, raise your hand. Now I have another question. How do you know how a lion looks like? Why do you know a lion looks like that? Because I've seen, teacher, a lion. I've seen pictures. I've seen videos. Teacher, my mommy brought me to the zoo. Okay. All right. You know how a lion looks like. That's good. You know how a lion looks like because you've seen pictures, or you've seen videos, or you've seen what a lion looks like in real life, right? Now let me ask you another question. Who here knows what an elephant looks like? Raise your hand. Very good. All right. Why do you know, or how do you know what an elephant looks like? Because I've seen an elephant, teacher. Yes, okay, you've seen pictures. I've seen a video, yes. Teacher, my mommy brought me to the zoo. Like, yeah. You've seen an elephant in real life. Very good. So you know what a lion looks like, and you know how an elephant looks like because you've seen examples of lions and elephants. Third question. Who here knows what an aardvark looks like? Raise your hand. Oh, there's like one person over there is like, Teacher, what's an aardvark? Well, let me show you what an aardvark looks like. Okay? Why do you not know, before I show you, like, why do you not know what an aardvark looks like? Because you haven't seen it, right? I haven't seen it, teacher. I don't even know what it is. Is it an animal? What is, teacher? You don't teach us well. All right? So an aardvark. So I Google over here, and this is what an aardvark looks like. Wow, what in the world is that? That's an aardvark. It's like a cross between a pig and a mouse and an elephant. Something like that, right? Yeah. So now if I ask you the question, who here knows what an aardvark looks like? Everybody, come on. Everybody raise your hand. Wow. Why? Because now you've seen an example of it. You've seen pictures of it. You're learning. Your brain is learning. You see examples, you now remember, you learn, and now if you see an aardvark in real life, you can tell, ooh, that's an aardvark. Right? And you can be like, so proud. Never felt so proud to know what an animal looks like. But the same way, the machine learns, right? A machine basically learns in the same way, based on examples. So you take a computer, you put in the fancy stuff like the neural network, the deep learning neural network, the whatever kind of machine learning framework you're using. But those are just the tools. It's just sort of like the empty brain. What's really important are the examples, right? You give the machine examples and you show the machine enough examples, it starts to learn what something looks like. So for example, if we show the computer pictures of lions and pictures of elephants and pictures of aardvarks, the machine will be able to start learning to tell the difference between these three things. And if you give it a new picture of a lion, an unknown animal, what is this? Then the computer will say, based on the examples I've seen before, this one's a lion, 80%. And you're like, very good computer. But then what if you show the computer a picture of a human? Caucasian, for example. Show him a picture. What is this? What do you think the machine will say? Yeah, very quiet machine, right? Is it hanging? So it will say, I'm looking at Caucasian right now. Elephant, lion, aardvark. I'll be very, very careful. Say me like lion 40% or something. Elephant 30% and 30% aardvark, right? It won't be able to tell that it's a human. Why? Because its whole world, everything it's just learned is just based on the examples you've given it. So it will only be able to say lion, aardvark, or elephant. Everything is based on examples. Now let's move from elephants and animals. Let's move it to a more practical scenario. For example, like accounting or banks or loan applications. Has anybody tried here applying for a credit card? Why is somebody laughing? Right? Credit card. Have you ever tried applying? Do you guys have credit cards here? You do? You never try to apply? What's that? They just come to you? How does that work here? So, okay, in my country, we have to apply to the credit card companies, right? And I hate this because they kind of like judge you, right? You fill out all this form, they ask you all sorts of personal questions like how many houses do you have? What's your address? Like how many cars do you have? What's the age of the car? I'm like, why does that even matter, right? But they ask you all these things. Why? Why do they ask you all these things? Did you know they're basically trying to assess like how credit worthy you are, in other words, how rich you are or how poor you are? It's because when you walk into a bank, for example, let's just role play. Have you ever been to a bank? You have banks, right? Guys, you gotta give me feedback or else I make all these assumptions that, are wrong. You guys have banks, right? Have you walked into a bank before? There are tellers in the bank, right? So these bank tellers, when they walk in there, there's always this one bank teller who's been there forever. And the moment you walk in, he or she just takes one look at you. Let's make it a she. She just takes one look at you and she already immediately knows whether you're rich or you're poor. One look. It's crazy. How come? How can she tell? It's because the moment you walk in and you ask her, how can you tell? She's like, it's the way they walk, the way they talk, the way their shoulders are, the way their hands move, the way their eyes twitch. I'm like, what? Yeah, it's a combination of that plus like the bag they're carrying, who they're with, how pretty or how handsome the person is or not, like what car they came in, where they, everything. So it's like, okay, so if I'm a junior teller, I go in there, so I just have to take note of how they walk. So how do they walk? Like jump walk or like casual walk? Like what is this? It's not just actually the walk, it's also the combination of all the other things. Wait, but so what is it? It's really hard to explain, right? Okay, so how do I learn this? Well, you just have to stay here and have years of experience. And after seeing many people walk through the door, you'll start to be able to tell. Like, that's gonna take a really long time. Yeah. You see, the teller has learned how to judge people because every time somebody walks in, they then open the bank account. All right, sir, your account number. Ooh, the balance. Ooh, sir, you don't have enough balance. So associated, the way the person looks and feels and smells and whatever, and then this is the balance. Then another person walks in, this is the balance. And after having done this day after day, months after months, years after years, the person has gained a lot of experience of examples of example and label or outcome. And so after having that for many years, they're now able to tell like, ooh, this one, okay, definitely. Hello, sir, you have a good balance. I haven't even opened your account yet, and I already know. You would like another credit card, right? But us, we walk in there, no matter how, we go like, good morning. We really spend time really showering and everything. They can see through us, right? Because they can see the pattern, all right? The pattern, what's the pattern? I don't know what the pattern is, but there's a pattern somehow. Can this person be wrong? Yes. But 80%, 90% of the time, because of the experience, they're correct. And this is what you call learning. Basically, this is human-machine learning. So, what they've done is they wanted to translate this into the machine. So how do you translate this human knowledge to the machine? What if, instead of the walk and the smell of the person, we ask them their address, who their father's name is, their age, how many wives, their wife, how many children, their cars, what kind of car, what year, where they went to school, and all of these other information, and we take that as the example, and we show that to the machine, and we show the person's balance or credit worthiness, and then we run that, and we have collected so much of that data, and then we let the machine see it. But instead of spending years, the machine doesn't have to wait for a person to come in, right? The machine can just process thousands, tens of thousands, hundreds of thousands, even millions of data in just a few minutes or hours and get the patterns from that. So instead of spending years, a machine can learn in a very short period of time. And so now you have a machine that can have an input of the profile of a person and output 80% chance this person has high balance or high credit worthiness. And it's simple as that. So that's exactly what some banks are already doing. That's maybe already what the bank already does, I don't know. But that's basically how machine learning works. You take a lot of data, label data, and then you put it into the machine learns to associate the patterns, extract the patterns that human minds can't see, but the machine can easily spot, and then it translates into a prediction mechanism. Prediction in what sense? Prediction that when you walk into the bank, they give you a form, they ask you to fill it up, and you fill it up, and then they feed it into the system, and the system goes, denied. And then you ask, why was I denied? And sir, I'm sorry, sir, it's the system. But why? See, I put there, my number of cars is 5. Yes, sir, but it's still denied. So basically, that's how machine learning works. I'm not so sure if you like that example. Like, suddenly people are very sad. Like, oh, how am I gonna get a credit card now? It's like, all right, but that's basically how machine learning works. Does that make sense? So fundamentally, you need data. You need examples. That's why they say you can't run machine learning if you don't have data, because it's all based on examples. Now, enough talk, enough explanation. Would you guys like to see a demo? Yes. All right, I can hear an affirmative yes. So I'm gonna do 2 demos today, 2 sets of demos. First one is I'm gonna do something from Tensorflow. So what is Tensorflow? Have you heard of Tensorflow? Yes. Come on, guys. So Tensorflow is basically a machine learning framework by Google, because this is a Google event. And the internet is loading. There you go. It's an end-to-end open source machine learning platform. It makes it easier for developers to use machine learning. When I started using machine learning, about in 2016, this just came out, I tried to install it. It took a Googler 3 hours to install it on my laptop. And that Googler was from the TensorFlow team himself, right? It was like, I can do this, I can install it. It's like, yeah, it's running 2 hours. No, it's 3 hours later. Yeah, guy installed. I went back to the Philippines, that was in Mountain View. I went back to the Philippines, got my team to install it. It took us 3 days to install it. And in Windows, we gave up. So, that was 3 years ago. Fast forward to today, we have it so easy. Oh my goodness, you just press a button, it already installs everything. Sometimes you don't even have to install it, you just press a button, it runs Colab, and you already have like TensorFlow running on the cloud. Wow, you don't even need a good computer for it anymore. It's really, really cool. So what can we do with TensorFlow? Well, the demo that I'm going to do is we're going to try to classify we're going to make an image classifier. So we're going to classify pictures of food. Now, I showed this to Cation a while ago, and the food that I'm going to show is very much Eastern, like from where I am. It's pictures of, I have here, I call it Noodles AI. Hold on, let me open it. All right, Noodles AI. So I have 2 types of food. One is pancit. Do you guys know what this is? What do you call this? Crickets? What? So this is what we call pancit. P-A-N-C-I-T. Everybody say pancit. All right, okay. We got such an awesome stage here, guys. It's like a rock concert, and you guys are like acting like nerds and geeks. So, all right, so we have here pancit. So this is pancit, all right? Why am I showing you this? So that your machine learning neural network also there in your head starts to learn what it looks like, all right? So that's pancit. And the other category we have is called ramen, also known as Japanese ramen. So this is Japanese ramen noodles. So it's slightly different. It's still made out of noodles, but it is different because it is different, okay? That's Japanese ramen, okay? All right, there you go. Oh, are you hungry yet? Somebody said, I want my t-shirt first. All right, well, you get the food first before the t-shirt. All right, so there you go. So we're gonna make a classifier to categorize between these two. So in order to do this, I am going to get my command, and I'm gonna put it in my, where's that? Code, VS Code. So this is a live demo. A lot of things can go wrong in a live demo. So whenever I have something that goes wrong, you have a role. You have to encourage me and support me, okay? You have to give a big round of applause, okay? All right, let's practice. Round of applause. All right, let's do this. Okay, so, all right, so we have a command. We always copy-paste stuff, so this is good. All right, so we have here Python retrain. So what do I do with this? I just copy this thing. What I'm basically doing is I am using something called Inception v3. So let me Google that, Inception v3 GitHub. So this is an image classification library by Google. Can you please increase my microphone audio so I don't start screaming? Increase it a little bit, yeah. Thank you. Oh, I need water. All right, so here we go. So what is Inception v3? So it's a deep learning neural network made by Google, trained on ImageNet, which is a really big image library that's already pre-classified. I think about 1,000 labels. So this is what it looks like. That's a neural network. To explain it to you, I am going, so there's a nice background. I'm gonna play also the Inception soundtrack from the movie Inception. Let's go play it. Is it playing? There you go. Ladies and gentlemen, this is Inception. What is Inception? It is made out of different layers. The yellow one is convolution neural network layers. The blue is average pool, then green is max pool, and pink is concat, which is like concatenate. Purple is dropout. I have no idea what this means, but they're like machine learning terms. Light purple is fully connected, and red is softmax. All right? So you have a convolutional layer here that goes into a convolution layer, and a layer again, and then it starts getting crazy over here. So an image basically goes in here, and then it gets convoluted, I guess, and then another layer, and then it's concatenated, right? Yeah, concat, and another layer, and another layer. This neural network is very deep. It's like a layer within a layer, within a layer, within a layer, within a layer. And if you go deep enough, you can get lost in here, and it's a dead end. But if you go the right path and get out, you go to this layer, but it gets crazier. All right? And then eventually, if you survive all the way to the end, you get a classifier which tells, oh, that's a dog. So what we're going to do here is I'm going to now remove the soundtrack because that is so like the feels, man. Okay, there you go. Oh, thank you for the round of applause. All right. So what are we gonna do? What we're basically gonna do is we're gonna take our images, pancit and ramen, and we're gonna push them through here. So these are already pre-trained. What does pre-trained mean? It means that Google already did all the hard work, and these are already properly configured to be able to classify 1,000 types of images. Like dog, cat, aardvark, lion, I don't know, bike, car, human, person, cockroach, whatever, right? So you have all of these things, but I don't want 1,000 different categories. I just want 2. For my personal application, it'll be noodle, pancit, and ramen, all right? So pancit and ramen. So what we're going to do is at the last step, we're going to reconfigure it, and we're gonna change it to only say 2 things. Either it's pancit or either it's ramen. And that's what we're going to do. We're going to retrain. And this is quite a very simple step. So what we're going to do is, we're gonna do what all developers do. Copy. And then we're gonna go here, CD desktop. Can you see it? At the back, can you see it? At the back, can you see it? Yes. All right. I can't hear you though, because you're at the back. Duh. All right. So here we go. We're gonna run this command. Python retrain.py, and let's hit it. And then, all right. Oops, there's an error. All right. Round of applause, please. All right. So I forgot to get my environment up. All right. Tensorflow and bin activate. All right. All right, so to make things more exciting, we're gonna also play another music here. Let's make it the Mission Impossible soundtrack. Because when you're looking at the terminal, it just has to be the Mission Impossible soundtrack. Where's that? Okay, from the very beginning, come on. There you go. All right, Albert. We're gonna have to retrain this thing. So, copy paste that thing. All right, so what does this do? Well, we're gonna call the script retrain.py, which is already there. We're gonna use the bottlenecks to store all the image data. We're gonna do 500 training steps, all right? 500 times of the computer seeing pancit, ramen, 500 times, right? That would be like, only a computer can survive that. Okay, we're going to use inception, we're gonna start, and then we're gonna call the retrain graph.pv. All right, can't wait. But most important part, categories is the image directory. Let's open that. Categories, yeah, categories. Let's do it. Enter. All right, okay, warnings. Oh, all right, it's working. What happened to my music? Oh, there it is, just very light. Okay, so what's happening right now? What's happening right now is creating bottlenecks. So each image is being pushed through the inception neural network, right? And then it's pushed to, and so the image is being converted from an image file to basically a bunch of numbers that the neural network can understand all the way to the end. All right? Okay, so still doing that. By the way, I'd like to appreciate my wife in the Philippines. We had to get like 100 pictures of ramen and 100 pictures of pancit, and she really helped me get all the pictures from Google. So thank you very much. All right, so you have that being still creating bottlenecks, 200 bottlenecks. So as developers, you know, what do you do when things are like this, right? Like you do nothing, right? Like you're like, what are you doing? It's training. Right? So what do? Well, you alt tab, you open Facebook, and for the next 30 minutes, you're still on Facebook, right? So instead, what I'd like to do is I'd like to do push-ups. All right, let's do this. All right, count. Oh my gosh, this side. Hurry up, computer. at least, right, if your scripts are slow, your body is fit, all right? So the people who are not so fit, you know their scripts are fast. Okay, so let's time to see if we can actually classify. So we need a picture. I like to use this search engine called Bing. Do you guys remember this? Because I got all my images from Google, so do not be biased. I'll get it from this other one. Okay? So images. Let's search a pancit. Okay, pancit. Alright, pancit. Okay. It's not so fast, guys. It's okay. Let's be patient. Alright, so somebody say stop. It's not loading. Somebody say stop. I mean, we didn't really mean stop. Let's go back to Google, guys. Sorry, babe. Pancit. All right, let's. Okay. Internet, folks. All right. Somebody say stop. Okay, stop. Haha. Okay, this one. All right. So I'm gonna take a screenshot of it, so that we're not downloading it. So I screenshot a segment of it. So now that we have that. Let's see. Where is it? Okay, it's over here. Okay, so we're going to put it in here. We're calling our labeler script, label image.py, and we're going to put it in. So where's that? Okay, and enter. Pancit, ladies and gentlemen. Round of applause for the computer. 98%. Okay. So now let's try ramen. Ramen. Oh my gosh. Somebody say stop. Oh. That looks more like bacon than anything else, but let's try it. Okay. Take a picture of that. Okay. Let's go Python label image.py. All right, where's that? Okay, that one. Are you pancit or ramen? And computer says ramen, 88%. Round of applause for the computer. So, as you can see, we made a classifier. But I think the real question we want to ask everybody is, Keishan, what are you? Are you a pancit guy? Or are you a ramen guy? Okay, let's search. Come on, faster. Come on. All right, Kishan. Oh, there you go. There you go. Kishan, you will find out what you are. What kind of food, or no, what kind of noodle are you? Alright, so let's close that. Python, label image.py. Can you tell us what Keishan is? Keishan, are you pancit or ramen? Keishan is 70% pancit. 29% ramen. All right. Okay. So, why maybe some of you are confused. Let me mute that. Maybe some of you are confused. Wait. That was Kishan. That was not pancit. Like, why are they laughing? Like, you see, the computer can only classify between the labels and examples that you give it. So, if you wanted Kishan there, we should have given the computer also 100 pictures of Kishan. Oh, you mean just 100? Why not 50? Why not 1,000? Well, actually, you can give more than that. In fact, it's better if it's more. But because I only had 100 pictures of pancit and 100 pictures of ramen, you want to keep it like balanced and the same. So this is what they mean when they say in machine learning, it's important that you have diversity of data. Because if our data is only like, like you have a classifier, and I don't know, I'm going to sound really weird here, but what if they have a classifier of like, that classifies between white people and black people? What about us brown people, right? So if they don't have that, they will only be between black and white. But the truth is, there are different shades of color, right? and there are different types of people, right? And sometimes they say male and female, and there's only two genders. But the world has not become just that now. It's much more complicated, right? Complicated. So your data has to be reflective of that diversity in the real world. So when you collect data from people, when you let them fill up the form to indicate their cars, there are people who are also creditworthy that don't have cars because we now have Uber and we now have Pick Me, right? And so people don't need cars that much anymore, even if they're creditworthy. So your machine learning examples have to reflect the diversity of the real world, right? I hope that makes sense. Okay, so if you want to do what I did over here, there is actually a code lab for this. It's called Tensorflow for poets. Like the people who make poems, yeah, that. TensorFlow for poets, and it's basically the exact same thing, except they use flowers, right? Flowers, dandelions, roses, daisies, and they use that, and my time is up. But yeah, so they use that, and basically you can just replace the flowers with your images, and then you can do anything from, you put there images of breast cancer and images of not breast cancer, and then you now have a classifier of no breast cancer or breast cancer. You replace it with images of x-rays with people who have pneumonia, and x-rays of people who don't have pneumonia, and you now have a classifier of x-rays that turns into pneumonia or not pneumonia. All right, so that's basically my example for TensorFlow. I just have a question. This is correct, right? I'm out of time? Okay, so yeah, if you don't want to do all the hard work, there is something called Google Cloud AI, which has all the different products like vision, speech to text, text to speech. So you have vision, like classify images. You have language, natural language translations, and natural language interpretations. You have conversation, speech to text, text to speech. You also have AutoML, which can do this for you. Just provide the images, you just provide the text, and it will do the training of the model for you. So you don't have to do it yourself. There's also these products by Google Cloud. But if you want to do it yourself, that's a TensorFlow for poets. So yeah, in the beginning, we had a lot of people who said that they know about machine learning, but they don't really know how, they haven't really used it. And there's only a few people who've actually done it. I hope that after this talk, you've seen it for yourself. It's not really that hard, right? So I hope that after this talk, you go transition yourself from somebody who's just heard to somebody who now does. So thank you very much, and I hope you learned something today.